Hello guys, welcome to today's class. In today's video, we'll be discussing differentiation, direct approach on differentiation. And in this particular topic, we'll be talking about algebraic functions, how to differentiate algebraic functions. If you are given an algebraic function of this form, y equal to ax raised to power n, then its derivative by direct approach will be dy dx equal to a n x n minus 1. A times n, a n, x n minus 1. That is the direct approach of differentiation for algebraic functions. Let's take some practical examples to better understand how to differentiate algebraic functions. Differentiate the following. 1. Y equal to 4x raised to power 3. 2. Y equal to x raised to power 6. 3. Y equal to 12x. And 4. Y equal to 5. Let's look at the solutions to this problem involving algebraic functions. Okay, so if you are given y equal to 4x raised to power 3, by direct differentiation for algebraic functions, we need to bring out our a. Here a is 4, n is 3. Thus, to differentiate this function dy dx, where we have an will be 4 times 3, then x n minus 1, 3 minus 1. This gives us 12x raised to power 2, and that is our dy dx. The next example, we have y equal to x raised to power 6. In this case, a here is 1, the coefficient of x raised to power 6 is 1, n is 6. And so by this direct approach, our dy dx will be a times n, which is 1 times 6, then x 6 minus 1. This gives us 6x raised to power 5. The next example, we have y equal to 12x. In this particular question, our a here is 12, our n is 1. And so applying direct differentiation, we have dy dx equal to an, that's 12 times 1, then x n minus 1, 1 minus 1. This gives us 12x raised to power 0. X raised to power 0 is 1, so this is 12 times 1, which gives us 12. dy dx is 12. For the last example, y equal to 5. If we express this function fully, we can write it as y equal to 5x raised to power 0. X raised to power 0 is 1 times 5 is still 5. And from this, we can see that our a is 5, our n is 0. Therefore, dy dx will be a times n, which is 5 times 0, x n minus 1, 0 minus 1. We already know that anything times 0 is 0. So everything here becomes 0. And that is the derivative of that function. With these examples, we can see the various forms of algebraic functions, how these algebraic functions can appear, and how their differentiations will look like. In summary, if you have y equal to axn, is dy dx is simply an xn minus 1. If you should have a case where a is 1, I mean y equal to x raised to the power n, a in this case is 1, dy dx will simply be n xn minus 1. If you also have a case where y equal to ax, where n is 1, as we can see in this example, is dy dx is simply the coefficient a. So whenever you see a function ax, a coefficient x, its derivative is just the coefficient. And if you see any function of this form a, constant form, is dy dx is equal to 0. As we saw in this case, when we differentiated 5, we got 0. So when you have a function y equal to any constant, is dy dx is 0. When you have a function y equal to ax, is dy dx is just the a. If you have a function y equal to x raised to the power n, you don't have your a anymore. You simply evaluate it as n xn minus 1 and so on. That's the simple way of differentiating algebraic functions. The next function we'll be discussing is the trigonometric function. We would want to discuss how to differentiate trigonometric function using the direct approach. If you're given a function y equal to sine x, then dy dx is equal to cos x. If you have a function y equal to cos x, then dy dx is equal to minus sine x. This is the differentiation of the basic trig functions. And if you can differentiate sine and cos, then you can manipulate any other differentiation of trigonometric functions. Okay, because every other trigonometric function is built on sine and cos. So the basic knowledge about trigonometric function you should know is how to differentiate sine and cos. Okay, and it's a very simple process, a very simple thing. When you have y equal to sine x, its derivative, its differential is directly cos x. Sine x, dy dx is cos x. But when it is cos x, y is cos x, its dy dx is minus sine x. You should take note of these basic derivatives of trigonometric function. Like I said, every other trigonometric function is built on sine and cos. And when you're asked to differentiate any other trigonometric function, what you simply need to do is to reduce to their basic form, the sine and the cosine. The next function to consider is the exponential function. And we'll see how to differentiate a basic exponential function. If you have y equal to exponential x, then is dy dx is still exponential x. When it is exponential x, is dy dx is still exponential x. This is the basic derivative of exponential functions. The next function we'll discuss is the logarithmic function. If you are given any function of this form, y equal to ln x, then is dy dx is equal to 1 upon x. This is a logarithmic function, and like I told you guys earlier, when I introduced functions and I talked about logarithmic functions, I told you guys that in calculus, we are more interested in log of natural numbers, the log of natural number, ln x. Now, but if you are giving logarithm to a different base other than base e, you have to transform from that different base to base e. So I'm saying ln x means log to base e of x. This is ln x, and that's what we focus on in calculus. log to base a. Now, if you are given a function in a different base, let's say you are given y equal to log x to base a and not base a to base a, you have to transform from base a to base e. You have to change the base to base e before you can differentiate. What you need to do to transform this is log x to base e. You take this value x to the new base e all over log a to base e, this to base e, this to base e. And from here you can see that this is ln, because log to base e is ln. This is ln x over ln a, where a is a constant. Is ln is also a constant value, so we can factor out the ln 1 over ln a, then ln x, and then we can now perform the dy dx on this. Where this is a constant, we can just keep the constant by the side and differentiate ln x. Later on, I will talk about various rules of differentiation, where we'll talk about the constant rule, the sum and difference rule, and many other rules. So if I want to differentiate this now, dy dx, I will simply keep 1 over ln a, then differentiate ln x. I will have 1 over x, and this is my derivative. With all of this, we've discussed the basic differentiation of various functions. We've talked about algebraic functions, how to differentiate a basic algebraic function, how to differentiate a basic trig function, how to differentiate a basic exponential function, and how to differentiate a basic logarithmic function. Now, but this function can compose other functions inside them, and it wouldn't be basic functions anymore. It will be a composed function of other functions. The next topic after now, we'll be discussing various rules of differentiation. Make sure you like and subscribe to this channel so you can get notifications when I upload new videos. And stay tuned for the next topic, rules of differentiation.